All right, let's do the same problems in MATLAB now that we did on the board. You can see over here in the command history on the right, down here, that I've been playing around with a bunch of different commands while I was prepping for the screen capture here. So let's start by pulling up the A matrix when I defined it. There it is. And just to make sure remember what the inverse is, there's the inverse. Now you can certainly invert a matrix as we did on the board using the determinant and the transpose of the cofactor matrix. Now it turns out the transpose of the cofactor matrix, which I had a C transpose on the screen, it has a name. It's called an adjoint matrix. Now again, when you're learning linear algebra, it seems like about half of what you're doing is learning names for things, and this is another one of those times. So an adjoint matrix is the transpose of the cofactor matrix. Why is it called adjoint? I don't know. Somebody gave it that name. It's as good as anything. So let's go ahead and say 1 over the determinant of A, okay, which we know to be, I think, -2, if I remember right, times the adjoint of A. That should give us the inverse. And there it is. It's the same. We get the same answer here that we do here. So we're sure we've got the right answer there. I'm going to clear the command window. Let's now use row operations to put a matrix in reduced row echelon form. Now, if you remember, the matrix we're going to start with is rectangular. It's not square. It's made of 2 square matrices. The one on the left is the original A matrix, and the one on the right is the identity matrix. So let's say maybe B equals A, and then EYE of 2. So just to remind you, EYE of 2, I of 2, is a 2 by 2 identity matrix. So if I hit return, you can see the left half of this is our original A matrix, and the right half is the identity matrix. So if I say RREF of B, which is RREF is reduced row echelon form, hit return, and what I get is again of 2 rows and 4 columns, 2 by 4 matrix, where now the left-hand side is the identity matrix, and the right-hand side is the inverse of A. So how can we be absolutely sure that we've inverted A correctly? Well, I mean, it's pretty likely that MATLAB got it right, but let's just go through the motions here. Let's make sure we've got it right. I'm going to make a variable called inv underscore A. I'm very sure that there's no command with that name, so that's okay. There we go. So if I multiply inv of A times A, I better get the identity matrix. And I do. So what happens when I do this in the reverse order? I also get the identity matrix. Now it's important here that in general, matrix multiplication is not commutative. You can't, A times B is generally not B times A. The exception here is that when one matrix is the inverse of the other one. So inv underscore A is the inverse of A, but A is also the inverse of inv of A. So it doesn't matter which order I multiply in, I'm still going to get the identity matrix both times. So I hope that helps. We'll talk to you next time.